Okay, but I like this negative 13 pi over 12 because, we got to do some thinking. And sorry, you could see probably a little bit of my answer there, so I want to move down a little bit. But I kind of cut it off. Oh, well, now I'm in the way. Get out of the way. Oh, I should close this. But yeah, I'm in protest. I don't want to be at school today as much as you do. We usually have a day off here, administrative, but that's fine. All right, so over 12. So here's my first thought. Okay, 13 pi over 12. I'm going to ignore the negative for a second. 2 pi over 12, that's nice. That's pi over 6, plus 11 pi over 12. 11 pi over 12 doesn't reduce, so I don't end up with a over 3, over 4, over 6. Got to try something else. 3 pi over 12 and 10 pi over 12. Interesting. 3 pi over 12 is pi over 4. 10 pi over 12 is 5 pi over 6. Nice. I got an over 4 and an over 6. That would be a good sum. That would be doable. Or, let's try another one just for giggles. 4 pi over 12 plus 9 pi over 12. 4 pi over 12 is pi over 3. 9 pi over 12, 3 pi over 4. Nice. That would also be another option. You have options. There will be answers that will look different depending on what the students are thinking. But I'm going to go back to that one and then insert those negatives as well. Lazy. So the first thing is you have to get an appropriate sum that adds up to the question and the thing, and then one that ends up being a 45, 30, or 60. And I got it. Next thing is let's go ahead and reduce. And then we can insert the things in the formula correctly. But before I do that, and by the way, why I'm not writing is I left my pen at school. Or I subconsciously woke up last night, cracked it over my knee, and threw it in the trash because I can't stand it. One or the other. I can't find my pen right now. So, what is negative pi over 4? This is like a note to self, or you might want to sketch it above there. Well, of course it's a 45, and if you don't know that, you're severely and totally and completely and way far behind. Ooh, that's a lot of adjectives. This is rough today. And then negative pi over 4 is in what quadrant? Okay, well, I don't know how my hands look right now, but you'd have to go clockwise, and it's in quadrant 4. I'm going to try to draw 4 with my mouse. Roman numerals. And then negative 5 pi over 6. We want to get this stuff down so we can do our simple stuff like what sine of a 30. And if you still don't know what sine of a 30 is, you're severely and totally and completely and absolutely behind. And then where does negative 5 pi over 6 land? Okay, you got to go clockwise through quadrant 4, and then you don't quite get to negative 6 pi over 6. You're in quadrant 3. These are all things from chapter 3, and we had to get knocked down here so that we can answer these questions quite fast. So what I mean about it being reasonable that I ask what sine of A plus B? Sine A, cosine B, plus signs are the same. It should already be locked in if you did your homework here. So here is the formula. Sine of negative pi over 4, cosine of negative 5 pi over 6, plus sine negative 5 pi over 6, cosine negative pi over 4. All right, and this is why I went through this. Oh, and by the way, a note to self. I made a really big point on this. Got to make a management decision. If you make this a sum of two negative angle measures, then it's the sum rule. And that angle measure is negative. If you made this minus 5 pi over 6, then this would be a minus, and this angle would be positive. And then you'd have a different quadrant. 5 pi over 6 would be in quadrant 2. You got to be able to handle that, right? But you can't convolute both. Either use the sum rule and make the angle negative, or use the minus rule and the angle's positive, right? And don't interchange those two things. All right, and then we should be able to answer this now after what we've talked about in class. What's sine of a 45? Root 2 over 2. But then also, what's sine of a 45 in quadrant 4? And then that's why I put this ASTC thing here. All students take calculus. So sine in quadrant 4 is actually negative. That's why I see a negative root 2 over 2 there. Cosine of negative 5 pi over 6, that's in quadrant 3. You got to be able to know that and get that, graph there and think about those. On the other side of that formula sheet that I gave you, it had the coordinate planes with all those angle measures. Get familiar. You obviously don't get to use that on Friday. It's supposed to be memorized kind of thing. Oh, and then what's sine of a 30? 1/2. So what's cosine of a 30? Root 3 over 2. But they're both negative because they're in quadrant 3. And then what's cosine of negative pi over 4? Look at the C circled in quadrant 4, positive, root 2 over 2. And then there you go. Those that do your homework, you're going to have these answers all end up being very similar. So you got a root 6, you got a root 2, and you got an over 4. So pretty nice. Remember what I told you, it's just the idea. Those that are going to go on mathematically, I think you'll be fine. If you ever had to go through this again in a college class and they go way further into formulas, the idea is the same, it's just a different formula. So I think we're good in the time that we have together here in this times that we're all in together. Waiting, and then I'm going to go to this one. I don't know if I had time to show you this one, but definitely will be on the test. Just a reverse analysis of these formulas. And by the way, at this point on the test, so the one test will be formulas and then a matching. Then you turn it in, and then you do the written. And on the written, I'll give you the formula sheet for the sum of angles, right? And I think that's all that really needs to be on there. Maybe the 90 minus ones as well, but. You'll get a formula sheet for this. This is not about memorizing the formula. It's about using it and recognizing it. So recognizing that this number out of the book, 16, is the sum rule for sine. But don't stop where I have this blue circle. I get this all the time, that students stop here and move on. They think they're done. No, sine of 90 can be evaluated. Sine of 90 goes through 0, 1 as a coordinate there, y over r, right? And then this one's also very similar, and I think you could see both on this. The recognition that is the difference formula for tangents, so reverse analysis, but then evaluating the tan of 135, which is a 45 in quadrant. All right. Oh, look, I drew a triangle too. I haven't drawn a triangle in a long time. Expecting you to kind of get used to these ratios over rote memorization. Asking you almost every day about, hey, what's sine of a 30? So on and so forth. Okay, just leaving there for a moment. And then, yeah, I'm even going to get on the students that have been doing their homework. I was a little disappointed on the homework. How many people didn't really try 72 and then 75. If we were here all year long in a full class, meeting every single day, you'd probably hear me say 2 or 3 days a week. You're a CAT student. You don't do nothing, you do something. You try something. If it doesn't work, fine, but at least, you see something in front of you, try some things that you've done in the past. And that really applies to number 75, and I'm going to go to that real quick. So a little disappointed in that. I was hoping I'd get more as I looked at that homework. I really only looked at yours, and that was 7th hours. Then I just got swamped with the math meeting. So here's 75. Might be smart to write this down, even though I have your homework, just note to self. On the test Friday, you'll have to prove at least 2 identities. So I'll be looking for the proper structure. Haven't had a chance to see a lot of your work. Some of your structures, though, from what I saw yesterday, not so great. You want to go straight down. We always write sine of x, not sine of error. There's got to be a variable after sine. There's a lot of things that I'm not going to like if we're not, we're being lazy on how we write stuff. So be careful on that for the written. This is what I mean about this one. To do nothing on this, I got a big problem with that, because we should know that squared means something times itself. Now, don't ever write this like this, but if you were to write another step, then write squared as this times itself. So just imagine a 2 sine x plus cosine x here. Then the next thing is distribution lines. And I even said that in the calendar. It's a FOIL, you know, so I do have a big problem with not doing anything. You got to do more, right? Give yourself more credit on that one. So 2 sine x times 2 sine x is 4 sine squared x. And then I got 2 sine x times cosine x twice. Don't ever let your work look like this. I'm being like this because I don't have a pen. But also, we should know how to FOIL without having to do this. I think I talked about this in August, September, when we reviewed foiling. To FOIL a squared set of parentheses, it's this times itself, 4 sine squared. It's this times this twice, because of what I just showed you with the lines, outer and inner. That's where I get the 4 sine cosine. And then this times itself, which is cosine squared. So there's the foiling of this. Then the other set of parentheses is another FOIL. I don't want this to go too far here, sorry. We're almost done. Then if you wanted to stick around for questions, fine. And the Adri, remember I have to talk to you. Okay, what? Uh-oh. And then this is this squared, and then this times 2. That's where I get the negative 4 cosine sine. And then this times itself, which is a positive sine squared. Okay, so again, in my class, you know, I don't make you write things, and it's okay, the other teachers are doing that, but this is perfect. If I saw this work, I know this person knows how to FOIL, and that work is completely, totally valid. The next thing is I wouldn't need an explanation, would not need an explanation of why you cross those off. Those are like terms, even though they're switched, like 4xy, 4yx, same thing. You know, a switched, that's just a commutative property. Going into this a little too much. And then I would group these two together, not really grouping, but I just put them and list them next to each other. Then I list the 4 sine squared and the 4 cosine squared next to each other and factor out that 4. Hey, everybody, what's sine squared plus cosine squared? 1. Okay, so that's why those turns into ones. 4 times 1 plus 1 is 5. 5 equals 5. Okay, so look at that structure. Look at the steps there. You'll have, I mean, I'm not saying it's going to be like this, but you'll have at least two identities that you have to prove through this structure of going straight down. All right. Okay, then tomorrow we got some more identity proving, but using the sum and difference and maybe some other, you know, different questions. So we'll do more proven identities. There's really only one day of this unit circle stuff, and then a little bit today about knowing sine of a 30 1/2 and so on and so forth. So I think I got 2 questions on the quiz that pertain to that, and we're moving on to chapter 6. The quiz Friday, be ready for it. Anyone that needs to make up that half sheet, it's done tomorrow. Come in after school. You don't have to email me, just show up. You guys are 7th hour, so just stick around. That would be easy. And anyone else that wants to stick around, that's certainly awesome. I truly enjoy actually working with people that want to be there. It's actually amazing. So, okay. All right, we'll see you. Go enjoy the day. Beautiful outside.